Hi and welcome to the 6th episode of this quadratics revision. This is working from question 6 onwards in the revision sheet that I've handed out in class. For those who are not in my class, you can just have a look at this and hopefully pick something up. Now, completing the square, if we remember we have, say, a plus b all squared, if we were to expand that out, that would be equal to a squared plus 2ab plus b squared. What we want to do is get the expanded term, this expanded form, and turn it back into, just going to fix up that plus in the middle there, like that, and we want to turn it into a factorised form of a perfect square. Now, with the questions we have here, that's not going to happen easily. We have to manufacture it. So I'm going to start by writing out the first one of these two examples, x squared plus 4x. Now, what we need to do is to get the coefficient of 4 and divide it by 2. And 4 divided by 2 is 2. So we're going to go plus 2 squared and take away 2 squared. That 2 has come from the 4 divided by 2, so if there had been 3x, we would have had, 6x. 6 divided by 2 is 3, so it would have been plus 3 squared and take away 3 squared. We have to add and subtract so that we don't change the overall value of the question, and then we need to get this plus 6 from the original question and bring that down as well. Next, what I want to do is take the first three terms here, and they become our bracket for the perfect square. So we have x plus 2 squared, take away 2 squared is 4, and plus 6. Now, where everything has come from is that we obviously have our x term that we bring down from there. We take that plus, if that was a takeaway, it would be a takeaway in the bracket, and the 2 comes down as well. So now to simplify this a bit further, we have x plus 2 squared, take away 4 plus 6 will be plus 2. And that's the answer to the first one of these questions. That's the square completed. Now for the second one, I'm looking in the coefficient of the x squared out the front, the 2, and wondering if that will go into everything because I need it to go into everything. So the first step I'm going to do is to factorize. Bring out the 2. I'll use some nice big square brackets. X squared plus 6 divided by 2 is 3, and 2 divided by 2 is 1. The next line that I have to do is to complete the square, so again I'll be using the first two terms. So we just write it out, x squared plus 3x. Now I need to get that 3 and divide that by 2, which is what I'm going to include in the question. So I go plus 3 over 2 squared. We have to square that. We add it and we subtract the same thing again. And then we have our plus 1 from the original question. Okay. So now I'll rewrite this again. 2 bracket. Now what I can do is I can take the first 3 terms from here and they become my perfect square. X, the sign is a plus there, so that goes into it. And we get our 3 over 2 squared. So that's now the perfect square part done. Now to finish the rest of this off, 3 over 2 squared, we square the 3 on the top. 3 squared is 9, and 2 squared on the bottom is 4. Then we go plus 1. Because we need to simplify these fractions at the end, or these terms at the end, numbers at the end, Dealing with fractions, I want to have them all in fractions with a common denominator. So 1 written as a fraction over 4 will be equal to 4 over 4. Now to simplify these fractions at the end here, they've got the common denominator, so we just deal with the maths on the top. So this will be equal to 2 x plus 3 over 2 squared. Minus 9 plus 4 will be minus 5. Like so. Now I need to get rid of that square bracket, so I'm going to multiply everything through. For the 2 in the bracket at the front, I'm just going to write the 2 out the front. And then I also need to multiply the 2 by the fraction at the end. So 2 times 5 is 10 over 4. 10 over 4 will simplify down to 5 over 2. And that's the first one completed. Let's move on to the next question. The length of a rectangle is 16 centimetres more than the width. Find the dimensions of the rectangle if the area is to be 80 centimetres squared. Now, always good to draw a diagram to represent this. So I'll draw myself a little rectangle here. The length of the rectangle is 16 centimetres more than the width. We don't know what the width or the length is, so I'm just going to call the width x. And therefore the length is going to be x plus 16. Then we are dealing with an area equation. So area equals length times width. In our case, we know that the area is equal to 80. Will be equal to x multiplied by x plus 16. Now what I'll do is I'll expand out that bracket, so that'll be equal to x times x is x squared, and x times 16 is 16x. And of course that's equal to 80. Now what I want to do is to bring the 80 across to the other side. So I'll take away 80 from both sides, and that will leave us with 0 is equal to x squared plus 16x. Take away 80, and the next thing we need to do is to solve this for 0. Probably the easiest way to solve this one for 0 firstly would be to factorize. So if I take the right hand side in this case here, what are factors of negative 80 that add up to positive 16? I think that might be 20 and negative 4. So this will factorize to become x plus 20 and x take away 4. These are equal to 0. And if we're going to solve this for x, we apply what's called the null factor theorem. So we set each one of those brackets equal to 0. So I'll do this over here. We've got x plus 20 equals 0. Take away 20 from both sides, x will be equal to negative 20. For the other bracket, x take away 4 is equal to 0, so we want to add 4 to both sides, x will be equal to 4. So I've got two possible solutions for x as being negative 20 or positive 4. Now it's a little bit hard to have a negative dimension of a rectangle, so we've only got one answer that we can have here, which is x is equal to 4. So the question says to find the dimensions of the rectangle. So in our case here, the width will be equal to 4, and the length is equal to 16 plus the width, which is 16 plus 4, which is equal to 20. And both of those units are in centimetres. That's that question, so let's move on to the next one. Okay, for this question, the height h metres of a stone t seconds after it is thrown vertically upwards is given by h is equal to 41t, take away 5.5t squared, that should be. So I'm just going to add that little squared there. Find the maximum height. So the type of thing this would represent is, as a very quick sketch, as a time or height versus time graph, is it's going to look something like that. Okay, so we throw it, reaches a maximum height, comes back down to the ground again. So the type of thing you'll want to do is use the symmetry of the function to find the maximum height. So it's going to be halfway between these two t-intercepts is where we'll find the maximum. So in order to do that, what I want to do is to factorize this function. So h will be equal to, I can see that t goes into both of those, so t is a common factor, comes out the front, and then we're left with 41 take away 5.5 t inside the bracket. Now, looking for where h is equal to 0, I can make this equal to 0 and then apply the null factor theorem. So we're going to have either t equals 0 or 41 take away 5.5t equals 0. Now if I rearrange that second one, we've got 41 equals 5.5t. Then if we divide both sides by 5.5, we'll get t is equal to 41 over 5.5. And 41 over 5.5 is also equal to 82 over 11 as a fraction. So we know that there's going to be a 0 intercept here, and the other one is going to be at 82 over 11. And that will tell us that our maximum will occur halfway. So 82 over 11, halfway point to that will be 41 over 11, of just half the top number. So when t is equal to 41 over 11, that's when we're going to find our maximum height. So what I'll do with that is I'll substitute it into the factorized form of the equation. So we have h is equal to t by 41 take away 5.5t. Substituting in t is equal to 41 over 11. And then we've got 41 take away 5.5 multiplied by 41 over 11. Now, that 5.5 will cancel down with the 11 on the bottom to leave it with 2. So that's going to simplify this to 40 over 11 multiplied by 41 take away 41 over 2. That bracket will just be equal to 41 over 2, so this will be equal to 41 over 11 multiplied by 41 over 2. And off the top of your head, you'll know that 41 squared is 1681, and 11 times 2 is 22. So our maximum height for this one is 1681 over 22, and you could throw that into a calculator and that would give you a value of 76.409. If you're after an exact answer, 1681 over 22 is the correct value there. For the next part of this question, what is the height at 3 seconds? So I'm going to substitute into the same equation. H equals t by 41 take away 5.5t, which will be equal to, we just substitute t equals 3, so 3 multiplied by 41, take away 5.5 times by 3. And if we throw that into a calculator, you'll end up with the answer of 73.5, or 73.5. Now for the next part of this, how long before the stone returns to the ground? The beauty of this is we've already worked it out. Right there, that goes down to there. 82 over 11 seconds. Okay, and then find the times for when the height is 60 meters. So what we'll need to do with this one is we'll go back to the original equation. 41t take 5.5t squared is equal to 60. So 60 equals 41t take away 5.5t squared. We need to bring everything over to the left hand side to set it equal to 0, so I'll add 5.5t squared to both sides. Take away 41t plus the 60 is equal to 0. Now looking at this, I think the best way of solving this would be to use the quadratic equation, negative b plus or minus the square root of b squared, take away 4ac all over 2a, where we have 5.5 is equal to a, negative 41 is equal to b, and plus 60 is equal to c. So I'll substitute this in over here. T is equal to negative of negative 41 is plus 41, plus or minus the square root of b squared, it will be 41 squared. Take 4 by a is 5.5 times by c, which is 60, all over 2a, 2 times 5.5, and this will be equal to 41 plus or minus, that plus or minus doesn't look very good, plus or minus, if I simplify this square root, 41 squared take away 4 by 5.5 by 60, that will simplify down to 361 over 11. Don't need that quite as long, do we? And if I take the square root of 361, that's actually equal to 19. So that'll be equal to 41 plus or minus 19 over 11. And let me just shrink this a little bit, fit the final answer in. So that will be equal to either 41 plus 19, which is 60 over 11, or 41 take away 19, which will be 22 over 11. So that will be the two times for when the height is at 60 meters. And that's the end of that question, so we'll move on to the next question. Consider the equation 2px squared. Put that little square up the top there. So consider the equation 2px squared plus p minus 1x plus 2p is equal to 0. Firstly, to find the discriminant, and hence find the values of p for which there are no solutions, one solution and two solutions. So our discriminant is equal to b squared take away 4ac. Now in this case, a is equal to the coefficient of x squared, which is 2p. B is equal to the coefficient of x, which is that bracket p take away 1. And C will be equal to 2p. Now this could end up a little bit nasty. So to substitute those into our discriminant equation, b squared is p minus 1 squared, take away 4 by a is 2p by c, which is also 2p. This will be equal to, so p take away 1 all squared, if we expand out that, will become p squared, take away 2p plus 1, and then we multiply these numbers together. 4 times 2 times 2 is 16, so that'll be take away 16p squared. So p squared take away 16p squared will give us negative 15p squared. Take away 2p plus 1. So that there, as nasty as it looks, is our discriminant. Now for the rest of this, if we're looking for no solutions, one solution and two solutions, we're going to be looking for references where the discriminant is equal to 0. If the discriminant is equal to 0, that's for one solution. If the, I'll actually write that, so that's one solution. If the discriminant is greater than 0, then we have two solutions. And if the discriminant is less than 0, then there's no real solutions. So our reference will be equal to 0. So what we need to do is to set that discriminant, we'll treat it as a quadratic function and set it equal to 0. So negative 15p squared take away 2p plus 1 equals 0. And then we'll apply the quadratic formula to this. So negative b plus or minus the square root of b squared take 4ac all over 2a. That will tell us our p values in this case. And that will be equal to negative b here. We have to ignore the ones that we had at the top there because we've moved on to a different equation, so just ignore those for this second part. Our a, b and c, in this case a is negative 15, b is negative 2 and c is 1. So negative b will be negative of negative 2, which is 2, plus or minus the square root of negative 2 squared. Take away 4 by a is negative 15 by our c is 1 all over 2a, so that's 2 by negative 15. And I'll just keep going across with this one, which is equal to 2 plus or minus. Now if I simplify that square root, 2 squared is 4, Negative times negatives are positive, so 4 times 15 is 60, times 1 is still 60. So it's going to be equal to 4 plus 60, which is 64, all over negative 30. Square root of 64 is 8, so it's equal to 2 plus or minus 8 over negative 30. So we'll then get two answers for that. 2 plus 8 is 10 over 30, which is negative 10 over negative 30, which is negative a third. Or 2 take away 8 is negative 6. Negative 6 over negative 30 is 1/5. Okay. So they're going to be our reference values. And now let me just shrink all this a bit. A bit more room there. If we look at this discriminant function as a very, very rough sketch, its discriminant's negative 15p squared. So it's going to be like a negative quadratic with two intercepts. One at positive 1/5 and one at negative a third, so it'll be something a bit like this. So we have 1/5 and negative 1/3. So when the discriminant is equal to 0, that's where it has one solution. So when we have one solution, then P equals negative a third or 1/5. When we have two solutions, then we're looking at where the discriminant is greater than 0. So that's going to be this section here. So that'll be negative 1/3 to P to 1/5. And for when we're looking at no solutions, we're looking for this bit back here and this bit back here. So when there's no solutions, we're looking for when P is less than negative a third and when P is greater than 1/5. And that's the end of that question there.